We will now look at how we use the normal distribution table to find the probability. We will start with finding probability for standard normal distribution, Z. Let's first look in detail the requirement needed when using the normal distribution table. There are two important requirements that we must fulfill to use this table. First, it must involve a positive Z value because all the Z values in this table are positive values only. And secondly, the area involved must be the area in the upper tail. If we do not fulfill these two requirements, then we need to do necessary modifications. We will look at the example for the detail. In example 12, we want to determine all these probabilities for Z. For part A, we want to find the probability that Z is greater or equals to 1.47. If we sketch this probability in diagram form, 1.47 is on the right of 0, and the area involved is more than 1.47. So this is the area that we need to find for the probability needed. Looking at this diagram, the Z is already a positive value, and the area involved is the area of upper tail. It is already fulfilling the two requirements needed to use the normal distribution table. So no modification is needed and we can directly refer to the table. The Z values are listed top down at the side with the second decimal listed sideways on top. Our Z value is 1.47 and the corresponding value inside this table is 0.0708. So the probability of Z greater or equals to 1.47 is 0.0708. Next, part B. We want to find the probability that Z is between negative 2.25 and positive 1.85. Let's sketch the diagram representing this probability. Negative 2.25 is on the left of 0 and positive 1.85 is on the right of 0. The area involved is the area between these two values. Now looking at this diagram, one of the Z value is negative and another value is positive. And the area involved is the middle area and not the upper tail area. So now we need to make some modifications here. The area involved here can be split into two parts so that we can deal with the negative Z value separately from the positive Z value. For the negative value, we need to make modification. Since a normal distribution is a symmetrical bell shape, we can reflect the negative Z to the positive side becomes positive 2.25 and the area still remains the same as before after being reflected. Now, both the Z values are positive. However, bear in mind, if we read the Z value from the table, it gives us the area of the upper tail. But the area that we want is the area in the middle. So what we can do is, for the first part, we can take half of the distribution minus the area of the upper tail of 2.25 to get the middle area. Similarly, for the second part, we can take half of the distribution minus the area of the upper tail of 1.85 to get the middle area. The area for half of the distribution is 0.5. And the area of the upper tail of 2.25 and upper tail of 1.85, we can get it from the normal distribution table. Upper tail of 2.25 is 0.01222. And the upper tail of 1.85 is 0.0322. That's how we get these two values here. So simplifying this, it will give us the probability that Z in between negative 2.25 and positive 1.85 to be 0.9556. Lastly, part C. We want to find the probability that Z is between positive 0.65 and positive 1.36. The diagram representing this probability is as shown here. Both the Z values are positive, so there is no need to modify them. Just that the area involved is not the area of upper tail. To get the area we want, we can use the area of the upper tail of 1.65 minus the area of the upper tail of 1.36. And the areas of these upper tails can be obtained from the normal distribution table. The upper tail of 0.65 is 0.2578. And the upper tail of 1.36 is 0.0869. That will give us the probability equals to 0.2578 minus 0.0869, and this can be simplified to 0.1709. This is how we use the normal distribution table to find the probability needed. To practice on the use of the normal distribution table, please refer to the exercise posted in Edmodo.